Hey everyone, ever get stuck on one of those algebra problems that just looks impossible? Today, we're going to tackle exactly that. We're talking about solving exponential equations, especially the tricky ones where the bases just don't want to match up.
Okay, so let's look at what I mean. On the left, we've got 2 to the power of x equals 8. You can probably just look at that and know, hey, that's 3, because 2 times 2 times 2 is 8. Simple. But then you get hit with something like the one on the right. 3 to the power of x equals 50. We know 3 cubed is 27, and 3 to the 4th is 81. So the answer has to be somewhere between 3 and 4, right? But how do we find out exactly what it is? That's the mission for today.
So, what do you do when you can't just make the bases the same? You need a special tool, a new strategy to get that exponent unlocked, and that is exactly what I'm going to show you, step by step.
And that special tool, it's the logarithm. You know, if you've ever sat in class wondering what logarithms are actually for, this is it. This is one of their biggest, most useful superpowers. They are literally designed to solve for exponents that are stuck up in the air. And the secret to using logarithms is a little something called the power property. Honestly, this one rule is the entire key to the kingdom today. It's what lets us take that variable, that x, that's trapped up in the exponent, and just bring it right down to ground level and turn it into a simple multiplication problem. It's a total game changer.
So here it is, our 4-step battle plan. This roadmap is going to work every single time. First, you get the exponential part all by itself. Second, you take the log of both sides. Third, you use that magic power property we just talked about. And finally, you just solve for your variable like you always do. Let's see how it works.
All right, enough talk. Let's put this strategy into action. We're going to start with that very first problem, the one that got us started.
Here it is again. 3 to the power of x equals 50. Okay, step 1 in our plan. Isolate the exponential expression. Well, look at that. It's already by itself on the left side. So, step 1 is done. We can jump right to step 2.
Now for the cool part. We take the common log of both sides. And watch, because of that power property, that x is no longer trapped. It just comes right down in front. And just like that, our equation is now x times the log of 3 equals the log of 50. The variable is free. And now for the final step. To get x all by itself, we just divide both sides by the log of 3. Now this right here, this is the exact answer. But it's not super helpful, right? So let's grab a calculator and see what it really means. And there it is. Punch that into the calculator and you get about 3.561. Just like we predicted, it's a number between 3 and 4. But now we know exactly what it is. Pretty satisfying, right?
So what happens when you run into an equation with that special number, the natural base, e? The process is almost the exact same, but we can be a little smarter about it.
Here's a pro tip for you. Whenever you see base e, you're going to want to use its best friend, the natural log, or ln. Why? Well, ln and e are inverses. They're basically designed to cancel each other out. It's a perfect match.
And check out how clean this is. When you take the natural log of e to the power of 2x, the ln and the e just disappear. You're left with just 2x. Our equation is now 2x equals the natural log of 15. So much simpler.
From here, all we have to do is divide by 2. We punch ln of 15 divided by 2 into our calculator, and we find that x is about 1.354. Easy as that.
All right, for our last example, let's look at one that seems a bit more cluttered. This is where step 1 of our strategy isn't just a step, it's absolutely essential. Remember what it was? Isolate that exponential expression.
So, before we even think about logarithms, we have to do some cleanup. First, let's subtract 3 from both sides. That gives us 5 times 2 to the x equals 40. Then we divide both sides by 5, and that leaves us with 2 to the x equals 8.
Hold on a second. Look at that. 2 to the x equals 8. This is one of the easy problems from the very beginning. We don't even need logs for this one. And that's the big lesson here. Always check if you can use the same base method after you've simplified. You might just save yourself a ton of work. Since 2 to the x equals 2 cubed, the answer is just x equals 3. A nice, clean, simple answer. It's a great reminder to not always reach for the most complicated tool in the box.
Now that you've seen the method work, let's talk about 2 really common traps that students fall into. If you can steer clear of these, you'll be in great shape.
Trap number 1 is taking the logarithm way too early. If you try to take the log of that whole messy thing from our last example, you get stuck. The power property won't work. You absolutely positively have to isolate that exponential term first. It's non-negotiable.
The second big trap is rounding too early. It is so tempting to find the decimal for log of 50, write it down, find the decimal for log of 3, write it down, and then divide. But every time you round, you create a small error. So keep that exact fraction of logs until the very, very end. Then put that whole thing into your calculator all at once. You'll get a way more precise answer.
So, why does any of this matter? Is this just some random thing you do in algebra class? Not at all. This kind of math is how we figure out real-world stuff, especially when it comes to things like money and investments. Check out this real-world question. How long does it take for your investment to double if it's growing at 4% per year? Well, the equation you'd set up is 1.04 to the power of t equals 2. And the only way to solve for t, the time, is with the exact method we just learned. The answer is almost 18 years. See? This is powerful stuff.
So we started with a problem that seemed like a dead end, but now you have the key, the logarithm, and you've got a solid 4-step plan to use it. This isn't just about passing a test. It's about having a tool that can unlock answers to real questions about growth, time, and change. The only question now is, what will you unlock with it?